66 million years ago, a colossal asteroid struck Earth, wiping out the dinosaurs and 75% of all other animals on the planet. It was a catastrophic event, and its effects reverberated across the Earth, causing massive environmental changes. But this happened millions of years ago, right? What if the same asteroid, or one like it, were to collide with Earth today? This is the question we're exploring in this scenario. Let's start by understanding the asteroid that caused this mass extinction. The asteroid in question is known as the Chicxulub impactor. It was no small rock in the sky. It was about 10 to 20 kilometers, 6.2 to 12.4 miles, wide, equivalent in size to about 100 to 200 football fields laid end to end. If this asteroid were heading toward Earth today, it would be coming in at a speed of 20 kilometers per second, about 12.4 miles per second, roughly 50 times the speed of a bullet. When this massive asteroid collided with Earth, it struck the Yucatan Peninsula in Mexico, causing a catastrophic explosion. There would be no escaping this event. In the blink of an eye, the immediate area around the impact zone would be obliterated, leaving behind nothing but destruction. But the impact wouldn't end there. Upon collision, an intense thermal pulse would radiate outward from the impact site, releasing energy equivalent to 10 billion nuclear bombs going off simultaneously. This massive release of energy would ignite fires, incinerating everything within thousands of kilometers. In the shockwave's wake, all life within a 1,500-kilometer radius would be utterly destroyed. This would include forests, animals, and any structures in the path of the blast. As the shockwave travels further, it would cause a magnitude 10 earthquake, one powerful enough to crack the Earth's crust. The tremors from this earthquake would be felt all across the globe, particularly in the United States. Mexico City, Florida, and Texas would be rocked by violent shaking. Even though Texas has discussed secession, I'm sure this is not the scenario they envisioned. But the devastation caused by the asteroid impact wouldn't be confined to just the immediate effects. The aftermath would bring about an environmental catastrophe of unprecedented scale. Large amounts of sulfur and dust would be blasted into the atmosphere, blocking out sunlight. For years, the Earth would experience a nuclear winter, with temperatures dropping dramatically. A prolonged period of darkness and cold would last for about 15 years. This global winter would make it almost impossible for most forms of life to survive, wiping out ecosystems across the planet. The few humans who might survive this asteroid strike would face a world of misery and hardship. With food sources destroyed and ecosystems in collapse, humanity would struggle to rebuild. It's a grim reality that the survivors would have to face. However, there's a twist in this disaster scenario. While the devastation of an asteroid strike is immense, it could also present a surprising opportunity. Asteroids, especially ones like the Chicxulub impactor, often contain valuable minerals, metals and rare elements that are difficult to access elsewhere in the solar system. After all, asteroids are rich with materials that are locked away in deep space, often far beyond our reach. But if an asteroid like the Chicxulub impactor were to land on Earth, we would have direct access to these minerals. For instance, this asteroid would likely contain enormous amounts of gold, up to $700 quintillion worth. That's so much gold that every single person on Earth could receive $93 billion. Additionally, asteroids contain valuable elements like cobalt, platinum, and nickel. Some of these elements, when subjected to the intense pressure and heat of an asteroid impact, can even transform into rarer, more valuable substances. A famous example is the discovery of the mineral rhyodite, found at a meteorite crash site in Australia. It was formed from zircon under the intense pressures of an impact. But beyond the gold and minerals, asteroid mining could revolutionize the way we source materials on Earth. Unlike traditional mining, which is often linked to environmental damage and human rights abuses, asteroid mining could be more sustainable. By extracting resources from asteroids, we could avoid the pollution of Earth's oceans and rivers with toxins like arsenic and lead. Additionally, the space environment itself is less likely to bring about the destruction of ecosystems or harm local communities. Of course, all of this depends on whether we could ever pull off such a feat. It's unlikely that we could mine an asteroid that lands on Earth using our current technology, but the prospect is tantalizing. And even though an asteroid collision with Earth might seem like a disaster, it could open up new avenues for growth and prosperity, provided humanity survives the initial catastrophe. But enough about the potential positives, let's take a step back and consider the full scale of this disaster. If the Chicxulub asteroid were to strike today, the immediate aftermath would be unbearable. The impact would cause wildfires that would devastate large areas of land. Oceans would churn and massive tsunamis would sweep across coastlines, furthering the damage. Earthquakes would shake the land, followed by a climate change event that would drastically alter the course of life on Earth. For those few humans who remain, life would be a struggle, likely requiring complete changes in how we live, farm, and generate energy. And if we didn't see it coming, if the asteroid appeared suddenly without any warning, the effects would be even more disastrous. In this case, evacuation efforts would be critical. Governments across the Americas, Mexico, the United States, and Cuba would be tasked with evacuating millions of people from the immediate impact zones. Entire cities would need to be relocated, and food and resources would become scarce. Refugees would flood into safer areas, and international cooperation would be essential for providing shelter, food, and medical care to those displaced. Yet, the real question here is, could we do anything to stop an asteroid from hitting us? The truth is, we may not be entirely helpless in the face of an incoming asteroid, but our options are limited. A few deflection methods have been proposed, and in 2022, NASA even tested one such method. The first approach is what scientists call a kinetic impact. This involves slamming a spacecraft into the asteroid at high speed, transferring its momentum to the asteroid and nudging it off course. This method was tested in 2022 with NASA's Double Asteroid Redirection Test, DART, which successfully impacted the moon of an asteroid called Dimorphos. The collision caused the asteroid to speed up slightly, but unfortunately, this method would not work on an asteroid as large as the Chicxulub impactor. We would need multiple spacecraft, each performing the same impact, to shift such a massive asteroid off course. A second method involves the concept of gravity tractor technology. This method involves flying a spacecraft close to the asteroid and using its gravitational field to slowly pull the asteroid off its path. While this sounds promising in theory, it would take a very long time to work and is only effective on smaller asteroids, those less than 500 meters in diameter. A behemoth like the Chicxulub asteroid would be too big for this technique. The third method, often referred to as ion propulsion, involves using the ion engine of a spacecraft to create a push on the asteroid. The ion engine produces a jet of charged particles, which can gently push an asteroid off course over time. While this is a highly efficient method, it wouldn't provide enough force to move an asteroid the size of Chicxulub. Another option being explored is the idea of using lasers to vaporize the surface of the asteroid. This technique involves focusing powerful lasers on the asteroid's surface, causing material to be ejected from the asteroid. The force of this ejection would provide a small push that could gradually nudge the asteroid off course. While this method is promising in theory, we would need extremely powerful lasers and precise targeting to make this work effectively. Finally, we have the option of using nuclear weapons. While sending nukes to destroy an asteroid sounds like something straight out of a sci-fi movie, it is a real consideration. By detonating a nuclear bomb close to an asteroid, we could vaporize a significant portion of its mass, pushing it off its course. This could be especially effective if we detect the asteroid early enough. Scientists suggest that detonating a nuke 2 months before impact could remove as much as 99.9% of the asteroid's mass, potentially saving Earth from disaster. However, the risks of launching a nuclear strike, especially with debris potentially falling back to Earth, make this an option we would want to avoid unless absolutely necessary. That's what would happen if an asteroid like Chicxulub hit Earth today: massive destruction and some surprising opportunities. But with the right tech, we might just avoid it. Thanks for watching Space Lab. If you enjoyed this video, like, subscribe, and hit the bell for more space content. Until next time, Keep exploring the universe.